let's talk about this formula. And the first thing in the numerator is d bar, the mean of the differences. The bigger this is, clearly, the bigger the value of t is going to be, and that makes sense. Let's say that we had done the experiment 2 different times. If the first time we had gotten an average difference of only 2, and the second time we did the experiment we got an average difference of 7, which would you be more likely to say, wow, this is an effect? Well, we'd feel better about rejecting the null hypothesis in this case because it looks like there's more improvement, and in fact the people have improved more. There's a bigger difference between the after and the before scores. But this difference is not the only story. What would happen if we had done the experiment twice and we had these 2 sets of data? This time in the experiment, same as the one we had on the previous frame, we have an average difference of 7. Here everybody's improved and there's an average difference of 7, but you'll notice the differences are not quite the same as these other differences. The differences are different, so to speak. And the real difference between them is the standard deviations are different. In the first case, this first set of data, the differences are pretty tightly clustered among one another. In the second, they're all over the map. They're fairly widely spread out. In general, the more consistent these differences are that we get, the more confident we are in rejecting the null hypothesis because the t-statistic is going to get bigger. In this case, we have consistent improvement, and here there's improvement either very little or a whole bunch. There's pretty much nothing in the middle, nothing in between. So the larger the mean difference is, the larger the t-statistic becomes, and with s in the denominator, the smaller the standard deviation, the larger the t-statistic, and therefore more likely to reject the null hypothesis. N is in the formula because we have to take account the number of observations. If you have 2 sets of data with the same average difference and the same standard deviation, the one with more observations is more likely to reflect the population than the set with fewer observations. Because n is divided in the denominator, it flips up to the numerator, and so the larger n is, the larger the t-statistic is going to be. And that is the t-test for dependent samples. What we're going to do in the next video is we're going to actually compute the t-statistic using the R statistical package.